In this video, we're going to look at a basic introduction to distance time graphs. Let's start off by drawing a distance time graph. We're going to have a vertical axis, or the y-axis, and that is going to be the distance from a fixed point. So this might be measured in meters or kilometers, for example. We're then going to have a horizontal axis, or the x-axis, and this is going to be the time elapsed. So let's go ahead and put this on. So we'll have t and we'll have d. So this is the distance from a fixed point. This fixed point, for example, might be home. So we might look at examples when you're 3 kilometers away from home, 5 kilometers, and so on and so forth. What we're going to do is graph a journey. The journey is me walking from home to the shops, getting something to eat, then walking to school, spending some time at school, and walking directly home. So what I'm going to have now is the time. I'm going to have hours, and I'm going to have 1, 2, 3, 4, 5, 6, 7, and 8. So the time is in hours. Then we're going to have a distance, and we'll take this in kilometers. We will have 1, 2, 3, 4, and 5. So this is the distance away from home, and we can say now that this is the distance in kilometers. So let's start off. I'm going to start off with a straight line, and this is going to be the first part of the journey. So I'm starting at home, a distance of no kilometers from home, and the time is 0. What I'm going to do is walk for 1 hour. So I've covered now in for 1 hour 3 kilometers. If this is a straight line, we have constant speed. So 3 kilometers in 1 hour. The gradient of this line gives us our speed. We're going to look more at gradients later, but as we can see, 3 kilometers in 1 hour. I'm now going to draw a horizontal line. If we have a horizontal line, this means that we're not moving anywhere. We're stationary, or if you like, we've stopped. So this is at the shops. So the shops were 3 kilometers away. It took me 1 hour to get there. I then went into the shops for half an hour, and I didn't move any further away from home. You can always argue that you're walking around, but essentially we're looking now at this to be a fixed point. After I've got my food and spoken to my friends, I'm then going to walk to school. So if I go ahead and do the next bit, I'm going to walk an additional kilometre. So this is 4 kilometres, and that is going to take me 1 hour. So from here, we can see now that the change in the distance is 1, the change in the time is 1, and we know that the speed is distance divided by time. We can see here that this is slightly flatter than this one, so I was walking at a slower speed. So after 2.5 hours, I make it to school. So long old trip. I'm then going to go into school and do my work, and then I'm going to stop that. At this stage right here, we can see that we've been at school from 2.5 hours to 7.5 hours, which is 5 hours, where we're stationary in terms of the distance from home. It's 4 kilometers. I'm then going to go directly home, and that's going to take me half an hour. So we've got now 4 kilometers in half an hour. So let's look at these sections. This now is a stationary section, so the speed would be 0. This is a stationary section. This length right here is half an hour. This length right here is going to be 5 hours. We have 3 different sections. This is going to be the first, and the average speed here is going to be 3 kilometers an hour. So we can say this is 3 km an hour. We're just looking how far we've travelled in how long. So it's 3 over 1. If we now look at this section right here, we can see now that we've travelled 1 kilometre in 1 hour, and this is going to be 1 kilometre an hour. So 1 kilometre an hour. A common error here is that students say, well, you've travelled 4 kilometres. We haven't, we've just travelled for 1. We've then got this final section right here. We can see we started 4 kilometres away. We've ended up back at home, and that's taken us half an hour. So if you wanted the calculation, it's 4 divided by a half, which gives us now 8 kilometres an hour. Or if you think to yourself, I've done now 4 kilometres in half an hour, what would I do in an hour? The longer or the further you go on with your studies, the more you'll use the gradient of a line. In this video, we're looking at this in a very basic way. So we can just say now that the speed is going to be the distance divided by the time. And of course, this now gives us the gradient of the line. So this one right here, the speed is going to be the distance, which is 4 kilometers, divided by the time in hours, which is half. How many halves go into 4? The answer now is going to be 8, and that would be 8 kilometers an hour. So we've looked at different sections. If we look at the total distance travelled, we've travelled 3 kilometers here, so let's put this on. And we can put these on. You can do this a few different ways. I'll do it a very straightforward way to begin with. If we look now, we've done 3 kilometers here, 1 kilometer here, and we've done 4 kilometers here. So we can see in total we've travelled 8 kilometers. You could of course work out an average speed by simply now adding the distances up and dividing it now by the number of hours. So that is an example of a distance time graph. So if we have these straight lines, we've got a constant speed. If we have a horizontal or flat line, we've got no speed, which means we're stationary, and we can say that the gradient of a line is the speed. So let's go ahead and answer some questions. It says find the speed for each of the following journeys. So let's look at the first one. We've started at 0. It's important that we check that we start at 0. We've done a distance of 3 kilometers in 2 hours. So we can say now that the speed is going to be the distance divided by the time. The speed is going to be 3 divided by 2, and we can say that that's going to be 1.5, and it will be kilometers an hour. We're given kilometers here and hours just here. This one, we can see we can pick this up at any point. We could look at this point right here. So we've done 1 kilometer in 2 hours, or we could look at this point right here, which is 2 kilometers in 4 hours. So it doesn't matter which one you pick up, we're just looking at the gradient. So we can say the speed is the distance divided by the time. All I'm doing is picking, with this one, it was nice to see this point right here, because none of these went over the intersection of the squares. So this one, I've got now, the speed is going to be 1 over 2, which is just here, and that's going to be, again, 1/2, and that will be kilometers an hour. If we look at this one, we could pick this point right here, or we could pick this point, or we could even work it out from this part right here. So I've got now the distance is 2, the time is 1, so we can say the speed is going to be 2 over 1. If you wanted to do this one right here, we've got now the change in distance, which is this one, 2, over the change in time, which is 1, and that gives us that. You could do 4 over 2. It's a straight line. The gradient will remain the same, so it's a constant speed. Okay, with this one, we just need to be a bit careful. A common error here is that students say, well, that's 6 divided by 4. But we've not travelled 6. We've only travelled a distance of 4. So what you might want to do is pick this point, or you might just want to read it off. We've done 4 kilometers in 4 hours. Or you might want to say to yourself here, I've done 2 kilometers in 2 hours. Or you might want to pick this point up, it really doesn't matter. Or you might just want to read off. Hopefully you can see lots of different ways. So the speed is going to be now the distance, which is 4, divided by the time, which is 4, or any one of these. So that's going to give us now 1 kilometer an hour. So do make sure you're given the correct units. If it's meters and seconds, it would be meters per second. Miles an hour if it was miles and hours. Okay, this one's going downhill. That's not a problem at all. We can pick any point. If you want to take the whole journey, you can do. That now is going to be a distance here of 20, from 40 to 20. And we can see that this is going to be a time of 8 hours. So we could say now that the speed is going to be 20, and then we're going to divide that by 8. 20 divided by 8 is going to give us 2.5, and that will be kilometers an hour. You can of course pick this point right here. So we've got 10 kilometers travelled in 4 hours. 10 over 4 again is 2.5. Just pick points where you're comfortable. Quite clearly picking this one would be useless because we're not going through a point of intersection of these. This one right here, we could pick the end points if we wanted, or we could pick this point right here. If we look at that one, we've got a distance of 60. We've taken 4 hours, so 60 over 4 is going to be equal to 15, and that would be kilometres an hour. If I pick this one instead, we've travelled 30 in 2 hours, which is going to give me now 15 kilometres. That is entirely up to you. Or if you want, just pick the gradient of the line. Okay, for each question, copy the axis shown onto square paper. Draw a line that represents each of the speeds shown. So on this one, 10 kilometres an hour, 40 kilometres an hour, and 5 kilometres an hour. So let's start with 10. The easiest way to do this is to start at 0, 0. So if we're doing 10 kilometres in an hour, we've got 10 and 1, 20 and 2, 30 and 3, 40 and 4. And all we would do is draw a straight line. So with the straight line, now it would look something like so. This is going to go through these points. So we've got now a change of 10 in the distance and a change of 1 in the time. If we look at 40, when we can go from 0 up to 40. So we've done 40 kilometres in 1 hour. We can see this line is steeper as it's a quicker speed. This one just here, 5 kilometres in an hour. We don't have 5 on this axis, but if we consider 5 kilometres in 1 hour would be 10 kilometres in 2 hours, and it would be 20 kilometres in 4 hours. So we can just simply pick a point of reference, and that would be now 10 divided by 2, which gives us 5, or you could say after 2 hours we're going to have done 10 kilometres. So this one was A, so that is for 10. This one is for 40, which is B, and this one is 5, which is going to be C. 20 kilometres an hour. So if we think about this, after 1 hour we're going to be doing 20 kilometres, and that will look something like so. So let's go ahead and put the line up. So that's what we'd have, 20 kilometres an hour. 10 kilometres an hour we would have now just here. There's 10 kilometres after 1 hour, 20 kilometres after 2 hours. If we look at this one, 2.5 kilometres in an hour. So what we'd have, and I'll put this on with a different colour as I'm going to do something slightly different here. After 1 hour we'd be somewhere here. Now that isn't sufficient. I know after 2 hours I'm going to have travelled 5 kilometres. 5 divided by 2 is going to give me 2.5, or if you like, you're doing 1 hour is 2.5, so 2 is 5, and so on and so forth. So that is an example. I've started all of these at the origin. I didn't need to, I could have put them anywhere as long as they're parallel. So if I look at this one now, if I moved it just here, then we have exactly the same speed. We can see here now that I've increased by 5 in 2 hours. I could put it anywhere up here as well. So if we look at that one, I could say now that I've increased 10 in 4 hours, which gives us the same. So if we have the same speed, these lines will be parallel. Right, let's move on and look at some more questions. In this one, it says copy each graph onto square paper and answer the questions. For each graph, find A, the length of time spent stationary. So we know with the stationary points now, what we're going to have is a flat line. It's a horizontal line. So let's start with graph number 1. We can see from here that that is going to be from 2 to 3, so we can say that this is going to be 1 hour. So I'm starting out with graph A. That's going to be 1 hour. The speed when moving for the first time. So we can pick any of these points. This is the first time. If we look, the easiest point is to take here. We've got 90 divided by 2. Speed is distance divided by time. So 90 divided by 2 with the correct units, 45 kilometres an hour. So do check this is in kilometres and hours. If we look at this particular part, for part C, the speed when moving for the second time, we've increased now by 30 kilometres, and that is in 3 hours. So we can say 30 divided by 3 is going to give me 10 kilometres an hour. Just go back to the idea that the speed is the distance divided by time. The total distance travelled, well, we can see from this now that that is going to be 120 kilometres. So the total distance travelled, 120 kilometres. The total time taken, we started at 0, we ended at 6 hours. The average speed for the whole journey. Well, speed is just distance divided by time. So we have 120 kilometres divided by 6, which gives us 20 kilometres an hour. Remember, if you're in an exam, do show full workings. I'm just writing them down as we're going to try and get through all of these. Okay, so let's now do this one. The length of the time spent stationary. Well, we started at 2 hours and we finished at 5 hours. So this would be 3 hours. I'm simply reading off now this point to this point, and that gives me 3 hours. I've checked now that the scale is the same as before rather than just jumping in, and we can see that each of these is 1 hour. The speed when moving for the first time. Well, the distance is 50 kilometres. The time is 2 hours. Speed is distance divided by time. So that's 50 divided by 2, which is 25 kilometres an hour. Speed for the second time, we're going downhill here, and we've got 50 and 10. So this distance right here is going to be 40, and we've done that in 1 hour. So this would be 40 kilometres an hour. Total distance travelled, we've not returned home. We've done 50 here, we've done none here, and we've done an additional 40 here. We add the 2, and we can say now that this is going to be 90 kilometres. The time taken is going to give 6 hours as before. And the average speed for the whole journey, well, we've got 90 divided by 6, and that gives us 15. So 15 kilometres an hour. So all we've done is simply gone ahead now and looked at the information. Okay, let's do this one quickly. The length of time spent stationary, that's 1 hour. The speed when moving for the first time, if we pick any of these points, look at that point, 20 over 1, 40 over 2. So we could say, or even taking this point, 60 over 3, 20 kilometres an hour. If we look at this one right here, we've got 60 kilometres, and that took us 2 hours. So 60 divided by 2 is 30 kilometres an hour. The total distance travelled, well, we've gone 60 and then back 60. 60 plus 60 is 120. The total time taken, 6 hours. The average speed, well, we've travelled 120 kilometres in the 6 hours. 120 divided by 6 is going to give us 20 kilometres an hour. So typical questions there where we've just read from the graphs. Okay, let's move on, and we're going to look at a slightly more challenging question. Each of the graphs shown below measures the distance of a particle from a fixed point along a path against time. So this is just one of the questions. So we've got distance in metres and time in seconds. So anything we're looking at in terms of speed will be metres per second instead of kilometres an hour. So for how long was the particle stationary all together? So if we look, we're working in seconds. We've got a stationary part just here and a stationary part just here. 5 seconds, then we've got 10 seconds, so we can say this would be 15 seconds. So let's just put this in. So 5 here, and then we've got now another 10 here. How far had it travelled after 10 seconds? So this is 10 seconds. We read up and we read across, and the distance is going to be 20 metres. So how far had it travelled after 10 seconds? So 20 metres. Find its speed when t is equal to 4. So t is equal to 4 is just here. So this is in the first section. We can see at this stage right here, the speed is the distance divided by the time. 20 divided by 5 is going to give us 4. So we can say that this would be 4 metres per second. So we can write it like so, or we could just write it as metres slash s. So that's for t is equal to 4. If we look at t is equal to 26, well, that's going to be in this section right here. If we look, the distance has decreased now, or I should say increased on here, the distance away from home. The distance is going to be 40, and that's over 5. 40 divided by 5 is going to give us 8 metres per second. So 8 metres per second. The total distance travelled. If we look at this, it's fairly logical that we can simply write down that this is 80. If you're unsure, you can add the sections. So what we have is 20 here to the point right here, and then of course we've got 40 here. All we'll do is simply double up this number right here as we end back where we started. So total distance travelled is going to be 80, and that is going to be meters. Average speed for the whole journey, well, what we have here is 80 meters divided by 30 seconds. So if this is in meters per second, let's just write this here. So we have the distance, which is 80, so average speed for the whole journey divided by 30, and that's going to give us 8/3, and that would be meters per second. So if you wanted to write that, that's going to be 2 2/3 meters per second, or you could say 2.6 recurring meters per second. So that's what we have now for the average speed. We've got now 80 distance, the distance covered is going to be 80. We've got now a time of 30 seconds. What was the average speed for the first 15 seconds? Well, if we look at the first 15 seconds, we've got 40 divided by 15. So let's put this in. So the speed is going to be 40 meters divided by 15. We can simplify this, dividing both of these by 5. That's going to give us now 8/3. And again, on there, 8/3 will give us exactly the same. So 2.6 recurring meters per second. So that's the first 15 seconds. We've travelled 40 meters in 15 seconds. Okay, next part. What was the velocity of the particle when t was equal to 4 and when t was equal to 26? Okay, now speed and velocity differ. Speed knows no direction. So speed is just the magnitude, the size of it. Velocity also has now a direction. This part might be beyond the scope of your course, but if we have now a positive gradient, then the velocity is positive. So we could say now at t equals 4, it would be positive 4 meters per second. The velocity in the second part, when we've got 26, this would now be negative 8 meters per second. So all we're doing now is looking, if we've got the change in the distance divided by time and it's negative, our velocity will be negative. So that one's done. What was the average velocity for the whole journey? Okay, again, this might be beyond the scope of your course, so I'll just bold these ones off. So if you've got up to this stage, most basic courses will only look at speed. When we're talking about the average velocity, we're talking about displacement. So displacement divided by time. When we're talking about displacement, we're talking about how far have I ended up from where I've started. The answer is 0 in this particular case. So the average velocity was going to be equal to 0 meters per second as we've ended up where we've started off. So if you're comfortable with everything up to F, that's perfectly fine. Those last two questions consider velocity instead of speed. So for example now, I'll just try and explain this now. Let's say that we have a particle moving along the x-axis. Okay, so let's say that we have now, this is 0 meters. So if I put a point here, this is going to be now 5 meters. If we looked at the displacement of each of these, we can say now that the displacement would be positive 5 meters, but this would be negative 5 meters. The distance is just 5 meters for each, but when we have now the displacement, we consider the sign of this, so that's 5 meters. In the same way, if I was travelling in this direction at 4 meters per second, or travelling in this direction at 4 meters per second, the speed of these are the same, but this would be negative 4 meters per second if we were looking at the velocity, because we're moving in the negative direction. So velocity has both direction and magnitude, which is the size, yet speed only has the magnitude. So that was a bit further than I wanted to go, given the sort of aim of this video, but hopefully that's given you a good introduction to distance time graphs.